This presentation is on wireless power transfer and its relation to electromagnetics. Pictured below is a phone being wirelessly charged by a wireless charging station. How wireless charging works. Wireless charging uses electromagnetics to transfer energy. It contains a transmitter with a coil which generates a magnetic field, and the receiver also has a coil that captures the magnetic field's energy. And essentially what's happening is the transmitter creates a magnetic field and the receiver converts it back to electricity. How this pertains to electromagnetics is this whole process essentially is Faraday's law and Ampere's law. Faraday's law being the changing magnetic fields create electrical currents, and Ampere's law, which is electric currents produce magnetic fields. Pictured to the right, to the top right, is a visualization of Faraday's law, where a changing magnetic field is creating a current, and below it is a visualization of Ampere's law, where current is creating magnetic field. So wireless power transfer relies on these magnetic principles to wirelessly send energy from a transmitter to a receiver. Applications. So the applications for wireless charging are pretty endless when you think about it. It might be on a smaller scale right now, but we see all the time consumer electronics, your smartphone, your smartwatch, your earbuds. You can buy a wireless charging station for those easily on Amazon, and medical devices, implantable devices, pacemakers, insulin pumps. These being wirelessly charged have huge impacts, because when you don't have to do surgery on a patient to replace a battery or any invasive procedures, it's pretty game changing. Electrical vehicles. Imagine in the future we have wireless power in the roads, or where all you have to do is drive and your car is charged. Robotics and automation, pretty self-explanatory. I mean, being able to not have to worry about cables and having a drone just land, charge, and go back up without any type of interconnecting wires for any type of errors to occur. Public infrastructure, being able to go into a cafe and all your devices charge while you're there. So the pros of wireless power transfer is the convenience. It's very easy to just put a phone or anything onto a device and not have to worry about wear and tear, your wires, and not having to worry about having the correct connector. Your cons are it is slower and it is less efficient than wire charging, coupled with a limited charging range. But if you have wires, you typically have that to worry about, though you can have an infinite wire length essentially. And that is my presentation on wireless power transfer. Thank you.